Example 6. A thorium-228 isotope which has a half-life of 1.913 years decays by emitting alpha particle into radium-224 nucleus. So calculate the decay constant, the mass of thorium-228 required to decay with an activity of 12 curie, as well as the number of alpha particles per second for the decay of 15 gram thorium-228. So the Avogadro constant is given. So what is given in this question? The half-life is given, which is 1.913 years. So we are going to convert that into seconds. So that is, we have 365 days in a year, 24 hours in a day, 1 hour is 60 minutes, 1 minute is 60 seconds. So that is 6.03 times 10 to the power of 7 seconds. So the decay constant is given as, the half-life, the half-life is ln 2 divided by the decay constant. So that is ln 2 divided by the half-life, which will give you 1.15 times 10 to the power of negative 8 per second. That is the decay constant. And then the mass of thorium, you need to know the conversion. So 1 curie, remember it is 3.7 times 10 to the power of 10 decays per second. Okay, so the activity is called A. So A is, they check up decay with 12 curie, so negative 12. Decay means negative, negative 12 curie. So convert that into decays per second. You will then times it, multiply it with 3.7 times 10 to the power of 10. So you will get negative 4.44 times 10 to the power of 11 decays per second. Okay, so that is that. And then since activity is also equal to negative lambda n, we will then get the value of n. So you will get 3.86 times 10 to the power of 19 nuclei. So we want the mass. So mass is n divided by Na times with the molar mass of thorium, which is 228 gram. The mass is given here. The number here is actually the molar mass. If I'm not mistaken, it's called as molar mass. Okay, so you times it with that. Instead of, this is molar mass, is it? I'm just gonna Google it. Molar mass. Is it known as molar mass? I am not sure, everybody, if it's molar mass. Atomic weight, is it atomic weight? I think it's molar mass, right? Okay, it's just molar mass. I'm just gonna call it molar mass. Okay, so the times it with the molar mass, which is the 228 gram. If it's incorrect, please let me know. Thank you. So you will get the mass to be equal to 1.46 times 10 negative 2 gram. Okay, and then question C, the number of alpha particles per second for the decay of 15 gram thorium. So 15 gram ni kita convert into n. So how do we convert it? Is we are gonna m divided by the molar mass times with the Avogadro constant. So you will get 3.96 times 10 to the power of 22 nuclei. So from here, you just have to use the this equation here. So just ignore the negative. So you will get A equal to 4.55 times 10 to the power of 14 alpha particles per second. Okay, sorry if it's really messy for you to understand, but if you do have problem solving this and getting the answer, please just message me in Telegram. Okay, all right, so that is on example number 6.